In case of halogen alkanes and alcohols, for halogen alkanes and alcohols, you will find that there is type of halogen alkane and alcohol to be primary or secondary or tertiary. For the type to be primary or secondary or tertiary, in case of halogen alkanes are CH2X, then 2R CHX, 3R CX, to be the same in alcohols, but instead of RX to be ROH. So you'll find that it will be R CH2OH, R 2RCHOH, 3R COH. After that, for oxidation, primary would be oxidized into aldehyde, then carboxylic acid. For secondary, it will be ketone. For tertiary, there is no oxidation. I explain why. Carbonyl group contains two hydrogen, so oxidation takes place two times. In the other one, carbonyl group contain only one hydrogen. The third one, there is no hydrogen to make oxidation. And then, for the reaction of halogen alkanes and reactions of alcohols, for reaction of halogen alkanes, RX can be reacted with H2O, NaOH, to be aqueous or to be alcoholic, and then reacting with NH3 and also reacting with KCN or HCN. In case of reacting with water or NaOH aqueous, it would produce ROH. This is in case of water or NaOH aqueous. In case of alcoholic, it will produce alkene. In case of NH3, it will produce RNH2, amine. In case of KCM, it will produce RCN, nitrile. This is the reaction of halogen alkanes. Like, for example, if you have CH3, CH2, Cl reacting with H2O, NaOH aqueous, NaOH alcoholic, NH3, KCN. In case of H2O, it will produce alcohol CH3CH2OH plus HCl. Why? Because in water, H and OH. So H will take Cl to be HCl and OH will be replaced. In case of NaOH, aqueous Na will replaced with Cl to be NaCl and also to be the same CH3 CH2OH. In case of alcoholic, you will find that Na will take Cl to form NaCl, and also OH will take another H to form a water, and then alkene CH2 double bond CH2. And all of these reactions substitution, except this reaction is elimination reaction. So all the reactions are substitution. All of these reactions substitution, except elimination reactions. This one is called elimination. After that, with NH3, NH2 and H. So H will replaced with Cl to be HCl, and the other one NH2 to be CH3, CH2, NH2. For KCN, K will take Cl, and then CH3, CH2, Cn. So this means that halogen alkane will produce alcohol, alkene, amine, and nitrile. In case of alcohols, the reactions of alcohols. You will find that alcohol ROH can be react with each of the following. React with HCl, BCl5, Bi3, SOCl2, and then it reacts with Na, and reacts with aluminium oxide. This is hot aluminium oxide or concentrated sulfuric acid or concentrated phosphoric acid, and react with carboxylic acid, and burns or combustion, and also can be oxidized by potassium dichromate. You will find that in this case, for the reaction HCl, BCl5, Bi3, SOCl2, all of them will produce the halogen alkane, RX, halogen alkane. But the difference that for each one, it will produce H2O, BOCl3, and HCl, H3, BO3, SO2, and HCl, while in case of burning or combustion, it will produce carbon dioxide and water, And also for oxidation, it will produce the aldehyde, then carboxylic acid, this is in case of primary. In case of secondary, it will be ketone. In case of tertiary, there is no reaction. And the color will change from orange to green in case of primary or secondary. After that, for the reaction with aluminum oxide, hot aluminum oxide, or concentrated sulfuric acid, or concentrated phosphoric acid, it will produce alkene. And in case of reacting with carboxylic acid, it will form ester. So again, for the reaction of alcohols, it can be react with HCl or PCl5 or Bi3, SOCl2. All of them will produce halogen alkanes, but the first one will produce halogen alkane and water for HCl. For PCl5, halogen alkane and BOCl3 and HCl. For Bi3, halogen alkane plus H3BO3. For SOCl2, produce halogen alkane and SO2 and HCl. And also for alcohol can react with sodium to produce RONA, sodium isoxide or mesoxide or like that. And then can be oxidized in case of primary will produce aldehydes and carboxylic acid, in secondary ketone, tertiary no reaction, and can be reacting. This also is called elimination reaction. This one is elimination. This elimination reaction. So we said before, elimination reaction in case of reacting halogen alkane with NaOH alcoholic, and also this case for alcohol reacting with hot aluminum oxide or concentrated sulfuric acid or concentrated phosphoric acid to produce alkenes is called also elimination reaction. And then reacting with acid to form ester, and by burning or combustion to produce carbon dioxide and water like alkane and alkene. And then you will find that these reactions of alcohols, all of them can be depends on primary or secondary or tertiary for the oxidation. For example, if you have a reaction of ethanol, CH3, CH2OH, and then if you're reacting with BCl5, HCl, BCl5, Bi3, SOCl2. All of these products will produce RX. So it will produce CH3, CH2, Cl. For the first one, it will produce plus H2O plus BOCl3 plus HCl plus H3BO3 plus SO2 plus HCl. While for the reaction with Na, it will produce RONA. So it will be CH3, CH2, this is R, O, Na, sodium isoxide, and then plus hydrogen gas evolves. You will find that you have fizzing or bubbles. Then the reaction was carboxylic acids, like ethanoic CH3COOH. You will find that it will produce ester CH3COOC2H5 plus H2O. This is making ester. And then, if reacting with hot aluminium oxide or concentrated sulfuric acid or concentrated phosphoric acid, you will find that it will produce alkene. And for burning and oxidation, you will find that it will produce aldehyde, CH3, CH2, CHO, and then oxidation to reduce CH3, COOH. For the first one, CH3CHO, and then CH3COOH. So you find that we have this alcohol will produce halogen alkane, and then this aldehyde, this carboxylic acid, and then this ester, and then this alkene, and also you'll find that for burning or combustion, that alcohols like alkane and alkene for burning or combustion with excess oxygen to produce carbon dioxide and water. This in case of excess amount of oxygen and in case of limited amount to produce carbon monoxide and water. And then for oxidation of alcohols, we said that for primary, we said that it will be CH2OH. These are CH2OH will be aldehyde, then carboxylic acid. Like, for example, if you have CH3, CH2OH, it will be oxidized to form CH3, CHO, then to be oxidized to CH3, COOH. After that, in case of secondary alcohols, to be 2R and then reacting with CHOH to form ketone. Like, for example, if you have CH3, CH3, CHOH to be oxidized to form CH3, CH3, C double bond O. For the third one, and tertiary, like if you have 3R and then COH, it will be no reaction. Like, for example, if you have CH3, 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 COH, by oxidation, no reaction. After that, in case of carboxylic acids, In carboxylic acids, the function group C double bond O OH. And then the reactions will be with metal oxide or hydroxide, metal carbonate or bicarbonate, and then reacting with LiAlH4 is the reduction. And then you will find that in case of reacting with metal, metal oxide, hydroxide, metal carbonate, all of them will produce organic salt. Plus hydrogen in case of metal. In case of metal oxide and hydroxide plus water. In case of metal carbonate or bicarbonate plus water and carbon dioxide. Like the reaction of neutralization between acid and base. This carboxylic acid to produce organic acid, but the same, this acid react with a base, metal or metal oxide or metal hydroxide, metal carbonate or bicarbonate. In case of reacting with a metal, salt and hydrogen, metal oxide or hydroxide, salt and water. In case of metal carbonate or bicarbonate, salt, water, and carbon dioxide. And then you will find that for LiAlH4, this is the reduction to produce ROH. Because in case of oxidation of alcohols, it would produce carboxylic acids. So for oxidation of alcohol, we produce carboxylic acid, and the reduction of carboxylic acid will produce alcohol. Like for example, if we have the reaction between carboxylic acid, like ethanoic acid, CH3COOH, plus Mg, it will produce CH3COO by 2 Mg plus H2. Hydrogen gas evolves. While in case of reacting CH3COOH plus NaOH, it will produce CH3COONA plus H2O. So with metal, salt and hydrogen, metal oxide or hydroxide, salt and water, metal carbonate like CH3COOH plus MgCO3, it will produce CH3COO by 2 Mg plus CO2 plus H2O. And for the reduction, if you have CH3CH2OH, and then by reacting with LiAlH4, it means that we have reduction. It will produce this for oxidation of alcohol to be carboxylic acid and returning back to be reduction. This by oxidation of K2Cr2O7, it will produce CH3COOH, and then when returning back by LiAlH4, it will produce alcohols. So alcohol will be oxidized into carboxylic acid and then returning back to form alcohol.